about to begin Chapter 10, Section 1. And I already uploaded a video that I've made previously. It's very detailed. It's very long. It's like 30-something minutes. But I highly recommend you watch that video. And it helps you through the homework problems as well. Right now, I'm going to record this and make this a more condensed video just to get you guys to understand it. But keep in mind, there's a longer video already uploaded. So please check that out. Right now, we're going to begin with comparing arithmetic and geometric sequences. So in the other video, we have the book, and it has all kinds of details and the notes and stuff. And instead of going through all this, again, you can watch that other longer video. I recommend it. Right now, we're just going to begin with writing down this fact. An arithmetic sequence has a common difference D. Please write that down. An arithmetic sequence has a common difference D. Arithmetic sequences have a common difference D. And then, after you write that fact down, let's write this fact over here. Geometric sequences have a common ratio R. I want to pause it, copy it down, and then we're going to move on. So as you guys are writing this down, you're probably thinking, what the heck is a sequence anyway, right? A sequence, according to the book, is a list of numbers that has some type of pattern, right? Some type of mathematical pattern. But to be specific, arithmetic sequence is a list of numbers that has a common difference, and a geometric is a list of numbers that has a common ratio. So you're probably thinking, well, how do I know whether I have a common difference or a common ratio? Let's take a look at our first example right here. It's 23, 17, 11, 5, dot, dot, dot. That dot, dot, dot means what? Continues forever, right? Okay, continues forever. Now you could already see 23, 17, it's decreasing, right? But the question is, do we have a common difference or a common ratio? And I really want you to write these notes down. Here's the answer, how to find whether you have a common difference or a common ratio. Pick a number and either subtract or divide the previous number from it. And I highlight previous because that's where the mistakes come from. You have to pick a number and subtract the previous one from it. That would make it a common difference if it's common in all terms. So again, I'm going to pause it right here, write this down, pick a number, either subtract or divide the previous number from it, and then in a couple of seconds, we'll continue. I'm pausing right now. So again, if we want to check to see if it's arithmetic, we're going to pick a number. I want to pick 5. Let's all write down 5. And I'm going to subtract the previous number from it. That's why previous is highlighted in yellow down here. You don't do 23 take away 17. That's wrong. You go 5 take away 11. So when I go 5 take away 11, what do I get? Negative 6. Okay. So if I go 11 take away 17, let me write that down. 11 take away 17, that's also negative 6. And if I go 17 take away 23, 17 take away 23, that's also negative 6. So we do have a common difference in all of its terms, okay? And this is why it's important that we highlight previous, because you want to take a number, subtract the previous one from it, okay? Subtract the previous one from it. Do not go 23 take away 17, that's going to be wrong. Because you see, when you look at these numbers, if I asked you, what's the difference between 11 and 5? What's the difference between 11 and 5? 6, right? The difference is 6. But the way to figure out what the common difference is, see, 6 is not the common difference. The common difference is 5 take away 11, which will make it a negative 6. Now, this is how we get other numbers. See, 23 plus that negative 6 plus that common difference of negative 6 will get us to the next number, 17. Plus negative 6 is 11. Plus negative 6 is 5. So what would the next number be? Negative 1, right? That's good. Since we're talking about which numbers are where on the list, we might as well also state this. The first number on any sequence, the notation is going to be a sub 1. A sub 1. The second number on any sequence will be a sub 2. The third number on any sequence will be a sub 3. The fourth number on any sequence will be a sub 4, and so on and so on. So I'll tell you this, on the quiz that we have, the first quiz on chapter 10, I will give you a sequence like this, and I will ask, like, what is a sub 6? And you would say what? What is a sub 6? Negative 7, right? Again, 23 plus negative 6, or 23 minus 6 is 17. 17 minus 6 is 11. 11 minus 6 is 5. 5 minus 6 will give you a sub 5. That's negative 1. And a sub 6 will be negative 7. Of course, I could ask you for a sub 8, which would be what? Negative 13. Does that make sense? I could also ask you for a sub 99, but that sounds crazy. Later on in the week, or maybe even early next week, I'll show you guys a certain formula to be able to find the 99th term without having to subtract 6 99 times, right? So we'll have a formula later. Anyway, this is a great example of an arithmetic sequence. It's arithmetic because, why is it arithmetic? Because there's a common difference, D, being negative 6, okay? So what does that mean? If I were to go 5 take away 11, get negative 6, negative 11, or 11 take away this number and get negative 6, but then I go 17 take away whatever this number is, let's say it was a 24, and it's not negative 6, then it would not be common, then it would not be arithmetic. You would just say neither, right? Well, actually, let's move on to geometric. Geometric, here's a list. Please copy it down. 27, 9, 3, 1, ... continues forever. So if you try to check and see if it's arithmetic, if you go 1 take away 3, let me write that down. 1 take away 3, that's negative 2. But if I go 3 take away 9, that's not negative 2 anymore, that's negative 6. So right there, the difference is not common. So that means that this guy cannot be arithmetic. It cannot be arithmetic. So now the question is it geometric? In order to have a geometric sequence, you have to have a common ratio. So does anybody remember what the word ratio actually is? Ratio. Okay, and when you say 1-to-1, you start thinking fractions, right? And that's what a ratio is. It's a fraction, right? So does it have a common fraction? So how do we figure that out? Again, pick a number and either subtract. We already tried subtracting and did not give us a common difference, or divide by the previous number. So if I say 1 divided by 3, okay? If I say 1 divided by 3, 1 divided by 3, I want to write it as a fraction, 1 divided by 3, and there's nothing I could do with that. Even if I did it on a calculator, it's going to be 0.33, and it continues to repeat, okay? But let's see if it's common in all of its terms. So if I go 3 divided by 9, 3 divided by 9 as a fraction is 3 divided by 9, and that also reduces down to 1/3, which is also the decimal number 0.33, and it continues, right? So it looks like it's common, but it has to be in all of its terms. So let's go with number 9 divided by 27. 9 divided by 27, might as well write it as a fraction. That reduces down by 9, and it reduces down to 1/3. So yes, it's the same common ratio. So right here we could conclude, yes, it's geometric because common ratio is 1/3, or 0.333333 forever, right? So it is geometric, okay? So just for funsies here, what is a sub 2? Which that might be a question on the quiz. What's a sub 2? 9. You don't have to do any math. A sub 2 is just saying, look at the second number, that's 9. What's a sub 4? 1. Cool. What is a sub 5? It's 1/3. It's 1/3. Again, the common ratio or the common difference shows you how to get from one number to the next, right? If it was a common difference of, let's say, -5, you go 27 minus 5, you get that one, -5, you get that one. But this is not a common difference, this is a common ratio. So what does this mean? 27 times 1/3. If you did that on a calculator, 27 times 1/3, it will be 9, right? Or if you work it out, 27 times 1/3, that becomes 27 thirds, which is 27 divided by 3, which is 9. 9 times 1/3 is really 9 thirds, which is really 9 divided by 3, which is 3. 3 times 1/3 is really 3 thirds, which is really 3 divided by 3, which is 1. Does that make sense? So the next number over, the a sub 5 term, that will be 1/3, because 1 times 1/3 is 1/3. What would a sub 6 be? 1/9, because 1/3 times 1/3 is 1/9. What's a sub 7? 1 over 27. That's right, because the 1/9 times 1/3 is 1/27. Do you guys get it? I hope so. All right. So that's the major skill that I want you guys to learn today. Is it arithmetic? Is it geometric? Or is it neither? Let's do one more example here. Some of us might be thinking, well, this is neither, because this is positive and then negative and then positive and then negative and then positive. Like that doesn't make sense, but it actually does. It doesn't make sense for a common difference. There's definitely not a common difference. If you do 16, take away a negative 32, that's going to be a positive 48. But if you go negative 32, take away 64, that's not going to be a positive 48. So there's definitely not a common difference. This for sure is not arithmetic, but maybe it's geometric. All right? How do we tell if it's geometric? I need to do what? Division, or a common ratio, right? So let me ask you this. What is the common ratio here? And don't think too much about it. Just give me a number and put it over the previous. Okay, negative 1/2 is the correct reduced answer. Could anybody just give me what you see with the numbers here? But you're right. 16 over negative 32. So if I did that, 16 over negative 32. Positive 16 over negative 32. That reduces down to negative 1/2. Okay, what if I did negative 32 divided by positive 64? Negative 32 divided by positive 64. What do I get there? Negative 1/2 as well, right? What if I did 64 divided by negative 128? 64 divided by negative 128. What do you get there? Negative 1/2. So it looks like it's a common ratio, right? So it looks like it's geometric, but what's the problem here? It's not really common. If you go to the negative 128 divided by 146, that is definitely not negative 1/2. So that messes it all up. So this is an example of no, it's not arithmetic. No, it's not geometric. It's neither. Neither. Make sense? So if we look at arithmetic sequences, a list of numbers, and graph that list of numbers, and also compare it to a geometric sequence, a list of numbers, and graph that list of numbers. First of all, you're probably thinking, what do you mean graph a list of numbers? Well, right here, this one is, I think the first number is 4, and then 8, and then 12, and then 16, and then 20, ... It continues forever. So a sub 1 is 4, so that's why the 1 down here, the a sub 1, your first number is 4. The second number is 8. The third number is 12. You guys understand how the graph is? But we know that this is arithmetic because it has a common difference. What's a common difference? 4, right? Because if you take a number, subtract the previous one, 8 take away 4 is 4, 20 take away 16 is 4, 16 take away 12 is 4, 12 take away 8 is 4. Don't go this way. Always pick a number and subtract the previous one from it. But my point here is visually on a graph, because it's always constant, you're adding 4 to get to here. You're adding 4 to get to there. You're adding 4. It's going to be a perfect straight line. Now, when you talk about a geometric, that's when you're not adding or adding a negative. That's when you're multiplying either by a number or by a fraction. And in this case, it's like you have a number, like the number 1, and then you multiply it by 3. And then you multiply it by 3, and then you multiply it by 3, multiply it by 3, and it just keeps growing exponentially. So the visual difference between arithmetic and geometric is that you have a line on arithmetic because that common difference keeps it a straight line. But when you start multiplying and multiplying and multiplying and multiplying, it grows exponentially. That's not really important on this section, but it will be in future sections of chapter 10. Right now I want to jump to the practice. We're doing page 663, numbers 1 through 19 odd, skip number 9. And you guys, this is on Google Classroom. This is what I want you to work on the rest of the period. The solutions are also attached right there. If you actually want to see me work out half of these on video, go to the other longer video. I explained the majority of these on that video. I just want to explain how easy this section is. This first section, they don't even say, is it arithmetic, geometric, or neither. They just say, is it arithmetic, yes or no? Wow. So all you're doing is there a common difference, right? So let's look at number 1. What do you think? Is there a common difference there? What is the common difference? What's a negative 22 take away a negative 12? Maybe we should write this down. Maybe I will do an example. What's negative 22 take away a negative 12? Negative 10. What's negative 12 take away a negative 2? Negative 10, right? So it looks like there is a common difference, right? How about, what about negative 2 take away 8? Yeah. So what could you say about this sequence? Absolutely arithmetic. Make sense? So you would just say, yes, arithmetic. If somebody were to ask you, why is it arithmetic? Because there's a common difference of negative 10 between all of its terms, okay? Now this next part of the homework, this is where it gets a little more fun. It says, find the next 4 terms of each arithmetic sequence. So they're telling you it's arithmetic. I mean, you don't have to check and see if it's a common difference. It is. They're telling you it's arithmetic. Like 30 take away 18 is what? 12. 18 take away 6? 12. I mean, you could check if you want. Yeah, it's a common difference at 12. So the question is, are you now able to find the next 4 terms? And on the solutions, they just give the next 4 numbers. I want you to actually use a notation for the 4th, 5th, 6th, and 7th numbers. So a sub 4 equals what? A sub 5 equals what? A sub 6 equals what? A sub 7 equals what? I would like you to do that on the homework. That way you'll get really comfortable with the notation. So when I do ask you what's a sub 7, you'll know what I'm talking about, right? But anyway, this is a sub 1, a sub 2, a sub 3. So what is a sub 4? 42. Yep, that's right, because the common difference is 12, and 30 plus 12 will get you to the next number, 42. Now, this is really ridiculously easy with the calculator, because if you type in 30 plus 12, hit equals, it'll give you the 42. To find the next one, all you have to do on the calculator is hit plus 12 again. 54. Yeah, and it'll give you 54. And then hit plus 12 again. 68. 66. My bad. And then hit plus 12 again. 78, and voila, we're done, right? Super easy. It's not till down here, we're skipping that word problem, but down here, the last part, that's where they say determine if it's arithmetic, if it's geometric, or neither. So this is the only one that's kind of challenging, but in reality, it's easy if you understand everything I've been telling you. So like right here, 1 take away 5, what's that? 4. Negative 4, right? But is that difference in common in all of them? Is 7 take away 1 negative 4? No, 9, so right there you know it's not arithmetic. Is it geometric? Is there a common ratio? What's 9 divided by 3? 9 divided by 3 is actually 3. But is 3 divided by 7 3? No, so right there it's simple. You would say neither. It's not arithmetic, it's not geometric, it's neither, right? So I would like you to practice these next, or practice with this homework assignment, 1 through 19 odd. If you want me to or want to watch the explanation of many of these, more than half of these questions, please watch the longer video. I'm done.